So we've reduced slash simplified, we've multiplied, we've divided. What more could there be? In this case, would be addition and subtraction. Whenever we're doing fractions, usually you kind of do multiplication and division first, actually, before you do addition and subtraction. Addition and subtraction is actually a little bit more complicated because you need an LCD, you need a least common denominator, right? You need denominators to match before you can add. And so that means that you need potentially, a lot of the time, especially if we're just sort of pulling examples out of thin air, you're going to need to do some adjustments. And when you do that, you're probably going to be multiplying. First things first, let's just look at an example where we're already starting with common denominators. So, what would kind of the nicest version of this be? Well, maybe something like this, where you have 4x over x minus 2 plus 2 over x minus 2. So x minus 2, those are a match. That means we should essentially be able to just combine this into one fraction, and we'll just add up top, right? This is essentially just going to look like 4x plus 2 over a single x minus 2, and then to a certain extent that's that. We do still have our restrictions. That's always in play. So in this case, our common denominator, x minus 2, is not allowed to be 0. So that means x is not allowed to be positive 2. But as long as we've noticed that, right? So then that's going to be where x is not allowed to be 2. This is it. I mean, that's the answer, right? If you have common denominators, you just add. Now, of course, you're talking polynomials, you're talking variables, so that means when you're adding, you're talking like terms. So in this case, right, on the left is 4x, and then on the right is just positive 2, the number 2, plus 2. 4x and 2 are not like terms, right? One is a variable term and one is a number term. So in that particular instance, we don't have like terms, but that's okay, right? Because all that means is you just sort of shift the addition up top and you just have them side by side, and that kind of looks like what we would expect. It just looks like another polynomial, right? So we've just sort of gone from kind of two individuals now to one with sort of a larger polynomial up top, and that's fine. You can do some factoring and sort of look and see if maybe it would reduce, but I'll sort of tell you for the most part off the top that they're probably not. They really shouldn't reduce. You can double check, this case, 4 times x plus 2. You could take a 2 out and it would be 2 times 2x plus 1. It's not really any better or worse, honestly. So I would say maybe just leave it like this. Let's do one little change. Let's do 4x over x minus 2 plus 2 over x plus 2. Dramatic music, dramatic, bum bum bum. So you hopefully will notice right off the bat, these are not the same, right? X minus 2 and x plus 2. The minus and the plus, obviously, the terms, x and 2 are the same, but minus 2 and plus 2, very different. We do get restrictions, right? Our restrictions here, we're going to get x cannot be 2 or negative 2. Let's just kind of mark that. And so what I need to do here is I need to build a common denominator, right? I need to sort of build from each of these two individual pieces, I need to build a common denominator that has them both. This is where you get into, so say you have, right, 2/3 plus 4/5 or something, right? You say, okay, these won't add because they don't have a common denominator. How do I get a common denominator? So in this case, 3 and 5 are already broken down as much as they can be. What you need to do is essentially multiply each fraction by the other denominator. So in this case, if you need a 3 and a 5 on the bottom, that means you have to multiply by 5 here. That would get you from 3 to 5 to 15, and then multiply by 3 here. But if you're going to multiply by 5, you got to match that in the numerator. If you're going to multiply by 3 over here, you've got to match it. So for us, in numbers, this would be 10 over 15 plus 12 over 15, right? Would get us to 22 over 15, right? Once they're in sync, you can add. So what's that going to look like here? Where now I'm not just doing numbers, I'm sort of doing this with sort of full algebra stuff. And the answer is, you know, it doesn't look super different. It's actually going to look almost exactly the same. So what I need to do is think of this not just in terms of minus 2 plus 2, but think of this whole thing, x minus 2. So I have an x minus 2 here. I need an x minus 2 over here. So I'm going to multiply by that, and then I'll match, right, that multiplication in the numerator. So what about on the left? Well, I've got the minus 2 here. I need the x plus 2. So I'll multiply by x plus 2, and then I'll multiply by x plus 2 up top as well, right? So I'm doing the same kind of thing that I did here. It's just kind of expanded and sort of looks a little more complicated because it's with polynomials and not just, you know, single numbers. But it's the same concept. It's really the same kind of idea. I, of course, have my restrictions in play. We'll sort of, again, bring those back in the end. But for now, what we can just do is say, so this is really like a 4x times x plus 2 plus a 2 times x minus 2, right, all over what would be our kind of common denominator, the pair, x plus 2 times x minus 2. And then the move to kind of clean this up is you're going to sort of take the multiplications here and distribute, right? So this would be kind of 4x times x would be a 4x squared. 4x plus 2 would be plus 8x, plus 2 times x would be 2x, plus 2 times minus 2 would be minus 4. So what you get, right, is a little bit of kind of fraction multiplication and some combining like terms. 4x squared, right, plus 10x minus 4 all over, so what was this? X plus 2 times x minus 2. And then that was where x is not allowed to be, what? 2 or minus 2. And that would be our final. You can, again, kind of do a little bit of a mental check here and say, you know, do I need to factor this out? What could come out of here? 2's could come out of here, right? Then this would be 2x squared plus 5x, you know, minus 2. Doing 2 times 2 is 4. Right, in the middle is 5. What's going to be minus 4? But positive 5, there's not a number pair that's going to sort of make that happen. So the top isn't really even going to factor. I'm not expecting it to. Again, the whole idea here is, you know, if you were going to be able to cancel an x plus 2 out of everything from the top, that kind of means it would have needed to be there initially in both of the numerator and the denominator, in which case you might have canceled it beforehand anyway. Let's do one last example. Let's do a subtraction one, I guess, right? We didn't technically do a subtraction. We'll kind of do everything in the kitchen sink. So let's do 3 over x squared minus 4 minus 2x over x squared plus 4x plus 4. So a couple things. Restrictions. So I know x squared minus 4 is not allowed to be 0. That would be x plus 2 and x minus 2, right? Not allowed to be 0, which means x is not allowed to be minus 2 or 2. Duly noted. The bottom over here, right? X squared plus 4x plus 4, not allowed to be 0. Factor, right? A is 1, B is 4, C is 4. So A times C is 4. We need to add to the B in the middle, which is also 4, it's got to be 2 and 2, right? 2 plus 2, and 2 times 2, positive and positive, would get us to 4. So that means this guy would factor as x plus 2 times x plus 2. This is actually another one of our special cases, a little bit less obvious to pick out what would be the sort of square of a sum. So x plus 2 times x plus 2 is not equal to 0. So this would just mean x is not allowed to be -2 or -2 again. Great, that's fine, that's cool. Okay, so here are my restrictions. X is just like really not allowed to be -2. Everybody agrees. And also it's not allowed to be +2. So those are all my restrictions. Let's take this original then, carry it down. So this is 3, all right, x squared minus 4 minus 2x, x squared plus 4x plus 4. Okay, so factor these guys out. This would be x plus 2, x minus 2, right, minus 2x, and then this is going to be x plus 2 and x plus 2. So this is kind of interesting, right? What we have here, rather than in the last example where we just had 2 different denominators that didn't really have any overlap, here we still have 2 different denominators, but there is some overlap, right? I mean, there kind of is the x plus 2 here and here. So then I really only need to kind of multiply by whatever is missing. And so that would mean like x minus 2 is missing, right, from the right. So I'm going to multiply by x minus 2, and I'll sort of match that up top. And then over here, well, I've got x plus 2 once, but I need that second x plus 2 to kind of get myself totally in sync. So that's going to be another x plus 2 here and here. So this is going to become, right, so this is kind of 3 times x plus 2. I'm shifting the sort of order of things here. My denominator is now, double x plus 2's and then a single x minus 2, right? Minus 2x times x minus 2. And again, all over the same thing. I'm actually could have written this at this point as one fraction. Could have saved a little bit of time there. So this would be combined, right? So this is going to be what? 3 if we distribute. 3x plus 6 over, so then this would be what? Minus 2x times x minus 2, right? X plus 2, x plus 2, x minus 2. This would be what? If I distribute minus 2x times x, so minus 2x squared, minus 2x times minus 2 would be plus 4x. Right? Again, all over. X plus 2 times x plus 2 times x minus 2. Good to go. And so all I'll do here is I'll combine my like terms up top. I'm also going to kind of rearrange this in descending order. So I'll do minus 2x squared up front. 3x and 4x would be plus 7x, and then plus 6 all over, right? I'm even going to go ahead. I'll say x plus 2 quantity squared, just so I have to write just a little bit less. So that's kind of my simplified version, and that was where our restrictions, bring them back. We're not allowed to be minus 2 or positive 2. X cannot be minus 2 or 2. Right, so that's my final version. I'm technically doing the addition here. I'm getting a new rational expression. It is kind of longer and messier. It's certainly not the kind of thing you would say is simplified, but technically that's the answer. I mean, that's kind of as good as it's going to get. That is the addition. That's what it looks like. So you get this little more complicated thing, but that's okay. That's what we're going to end up with. So that's the end of rational expressions. That's the end of chapter P. Nice work. We'll see you in the next lessons.